Old Time Gray here made me a big blue C-clamp. It's made out of 1-inch pipe, 4 welded pipe fittings, 2 big 1-inch 8 nuts, a 1-inch piece of ready bolt, a grade 5 3/8 bolt, a couple of 3/8 nuts, and a swivel. It opens to 11 inches. It's got a throat depth of 8 inches, and it can put some serious pressure on whatever you want to clamp. So this thing's big. Just to give you an idea, this is a 4-inch Cincinnati with a 2-inch throat. So quite a bit bigger. So I'll show you how I made it. The basic elements. So a piece of ready bolt and some nuts, a connector nut or two, an old rusty T fitting, 3 elbows, a swivel pad that I bought from McMaster, and a big old hunk of 1-inch Schedule 40 black pipe. So there's the kind of the corners. That's going to be the screw. This will be the fixed jaw, and then the C around these 3 elbows. And you may be asking, why the hell are you doing this? Just go buy one. Well, a couple things. First of all, a clamp this big, I found on the internet, 10-inch jaw opening and a 6-inch throat. It's $107. So I got all this for less than $30. I had that rusty T sitting around, and I had that piece of ready bolt sitting around, but I bought the fittings, I bought the swivel pad, and I bought this grade 8 bolt that's going to be the handle. So it's well under $30. The other thing is conventional C-clamps are basically an I-beam. This is basically an I-beam. Even the big ones, the basic architecture is an I-beam. Well, I-beams are great for resisting bending load that's going like this, that's trying to bend that I-beam. But they're not worth a tinker's damn at resisting twisting. And most of them fail like this. This is an old Cincinnati, I think, yeah, that I've had for years. But you can see how the fixed jaw no longer lines up with the movable jaw. The jaw pads are misaligned. That's because this arm is twisted. So when you over torque these things or you really reef them down, yeah, they can resist the bending all you want, all day long. You'll never bend this thing, this way or this way, but you'll twist it. And then once it's twisted, it really loses its clamp load. So the thought here is that the natural property of tubing is it resists twisting. It's not as strong in bending as an I-beam, but it resists twisting. So since twisting is the primary failure mode, we're going to try and address that even with this humongous clamp. I mean, this is big. Okay, since our $107 clamp is 10 inches, let's make it a little bit bigger than that. So including the jaw pad, let's make it 11. So that means the spine, which is this member down here, has to be a foot long. And then the $100 one has a 6-inch throat depth. So let's go bigger than that. Let's make it an 8-inch throat depth. Just because. Okay, so the top needs to be 6.5. So 2 pieces of 6.5. Close enough. Score a line. Okay, now throw some pressure on it. I'm going to try anchor lube on this. Works so good on drilling and cutting. Keep her straight. To get the lengths the same, I'm just using a piece of tape right where the cutter's got to go. So I'll scribe my line right on this side of that piece of tape. And should get them darn close. Okay, there's the line. Yep, there's the drive fit. Prep all these joints and tack it together. I love the smell of burning plywood in the morning. I just used my torch because I was just being lazy. I had it out, so I'll get the MIG gun out. Need a little shim under there. Looks like it did it. Yeah, that looks like it did it. Okay, for mounting the jack screw, looks like I'm going to need a longer piece of ready bolt. Oh well, I'll go buy that at the store tomorrow. Actually, I'm going to hold off on that. I might need to adjust that later. Went and got a longer piece of ready bolt and threaded it in, and it's hitting dead center right at the fixed pad. So this nut's in the right position, welds are in the right position. This is still loose, but I'm going to leave it loose and do the finish welding because the heat is going to start to move this around. So I might have to tweak and force and bend things a little bit as we go. Here it is in my vise. For the jaw pad, I'm going to use a thick washer. Looks like it's about 1 1/4 inch, 1.5 inches in diameter. And I'll tack that on first. And then I'll do the finish welding. About like that. And I'll plug the hole up in the middle later. But that looks about good. For the tacking operations, I'm using 23 thousandths wire, pure CO2, and I got my voltage and my wire feed cranked right up. So for the finish welding, I'm probably going to stick arc it because this stuff's pretty thick, and I don't feel like changing wires, so I'll probably just break out the stinger. Using 7018 1/8 inch rod. See how that works. I got her in about 70 amps roughly. Got a hole in that one there. I'll come back and patch that one up. This thing's getting hot, so I'm gonna stop for a little while, let this thing cool off. Again, even this big heavy stuff, you heat it too much, it'll start moving around. But we're still right on target with our lead screw, so I don't want to start warping this thing up. So I'll come back and weld it later, just let it cool off naturally. Well, there it is, all finish welded. I had to patch a couple of holes in here. I blew a couple holes in it. But the more I look at it, this 5/8 screw is looking too wimpy. Here's a 1 inch screw. That looks much better. So I think I'm gonna upgrade this to a 1 inch lead screw. I'm gonna chop off this nut and beef this up a little bit. It actually works right nice. I don't think I'm going to need a tailing nut on it. It's not a lot of slop between the ready bolt and the inside of that pipe. So I'm going to leave that off for now. I might not need it. If I need it later, I can always weld it on. So there's the frame, all welded up and grinded up. Still warm. Feels good on my old bones. I think I'm going to sculpt the welds a little bit more around the nut and around the fixed pad before I make up the lead screw. I'll do that now. Let's look at the lead screw now. So here's a normal, this is just a 3-inch, sorry, 2.5-inch old Wilton. And you can see there's finger clearance between the screw pin and the frame. So we'll make sure we leave some hand clearance down there. Then our swivel pad takes up some space, about yay much. So it looks like it wants to be about 18 inches long, all totaled. So I'm going to hold this in the vise, and so I don't gall up the threads, I'm just going to take a little bit of a pop can, or in this case, water bottle can thing, aluminum thing, and cut a soft jaw for my vise, and just use a pair of scissors. So I got her marked at 18 inches. And I'm just going to take my little aluminum jaw protector and a piece of masking tape and just wrap it around the pipe. Sorry, wrap it around the lead screw in the neighborhood where I need it for the vise jaws, like right about there. And clamp her on in. Okay, keep me from garfing up the threads too badly. Word to the wise when you're cutting something like this with the angle grinder, always cut from the top, don't come up from the bottom, because if she lets loose, it's going to drop, and this is heavy and strong enough that it'll pinch the blade. And I've had them blow up on me, where you're cutting something heavy underneath, all of a sudden it drops, but doesn't let loose, pinches the blade, blade stops, kicks the grinder back, and blade blows up in your face. So just go from the top and turn the device or the thing you're cutting as you go. I decided to upgun the screw handle to 3/8. So here's the frame, all welded up and grinded up and sanded down to 60 grit. And here's the lead screw with its 3/8 handle pin drilled in, which is nothing more than a 3/8 grade 5 bolt. I'd like to powder coat this, but I don't have an oven big enough, and I don't have a way to keep enough heat on it long enough to cure the powder coat. So I'm gonna have to paint it. Got this little shorty can of ocean blue Krylon, so that's gonna be the color. Should be enough here to finish the job. When you're spray painting, lay it on in thin coats. Don't gob it on, it'll just run. So just go on in thin coats, take your time. 4, 5, 6 thin coats, whatever it takes. When you're done with the coat, just wipe off the little orifice. I don't know if that's going to focus, but just wipe off that little orifice with a rag or a piece of paper. That's all you got to do. This nozzle's been in here for weeks, and this paint is not, it works fine. And here's the 3 pieces: the frame, the lead screw, and the swivel pad. Let's put them together. I'm going to put on a little bit of this lithium grease on the screw. Not a lot, but just enough to lube it up. Put some on the table too. A little bit of green Loctite. Put some of that on the table too. You really need a swivel on a clamp like this. If you don't, the end of this lead screw will just start walking around on whatever it is that you're clamping, and you'll never get it tight, and it'll twist itself. Big old diamond caulk adjustable, how to do it. There you go. I'm going to run the length of the screw to make sure there's no burrs or nothing on it. And there you go. Lines up perfectly. So we got here is 3 pieces of unistrut and a piece of 2x2 tubing. This is definitely a two-handed operation. You can see the pad in action. It stays still unless the screw turn. Okay, I can already feel probably that aluminum piece of unistrut giving way. So this thing's got some serious clamping power. Well, I'm going to leave this one here. Mission is accomplished. This baby's going into service. Already got some clamping needs for it. But for now, it's on to the next project, and I will see you there and then.